Hello, everyone. Let's go ahead and get started. And welcome to our webinar, How Hewlett Packard Enterprise Gets Real with IoT Analytics. I'm Dale Kim of Arcadia Data, and I'll be your host and one of the speakers. Joining me is Siamak Nazari, Chief Software Architect and HP Fellow of Hewlett Packard Enterprise. To quickly summarize his background, Siamak has many years of experience working on distributed and highly available systems. He is responsible for setting technical direction of the portfolio of software enhancements for the HPE 3PAR division. His current area of focus is solid-state storage systems and the software for a new class of storage systems. And I'm the Senior Director of Products and Solutions at Arcadia Data, where I guide strategy for our big data analytics platform. I've held a variety of technical and management roles at IT companies with significant experience in non-relational data platforms, including search, content management, NoSQL, and the Hadoop ecosystem. Now, before we get started, let me call out a few items. First, if you have questions on the webinar content along the way, please type them into the chat window, and we'll get to them after the formal speaking session of the webinar. If you have any audio problems along the way, please let us know via the chat window, and we'll try to address them. If we can't resolve the problem, be assured that you will get a recording of this webinar in a few days, so you can watch it again or even share that recording with your colleagues. And of course, please join in by live tweeting. The Arcadia Data handle is simply @ArcadiaData. Now let's get started with the webinar. Siamak will begin by describing how his team was able to solve an IoT analytics problem by using big data technologies. Siamak, take it away.
Thanks, Dale. Essentially, just to give you a background on what we do, we sell high-end storage arrays, tier 1 storage arrays for data centers. And over the years, we've sold a significant number of these storage arrays. These storage arrays report home a number of telemetry information. And what the business unit really does is supports all these systems out there. These systems provide tier 1 services such as database backends, SQL Server backends for our customers. And the customers are anywhere from small to medium-sized businesses to very large enterprises with hundreds of arrays at their site. At 3PAR, I'm responsible not only for sort of the architecting the system, but figuring out what the future system needs are. And we rely on this data that is coming back home to devise our strategy and figure out what we actually need to do in the future. The system has been designed for over the years, and there's been a lot of transitions in technology, and these transitions include the introduction of Flash. And all of our transitions in technology are guided by looking at the data and the customer use cases to be able to devise brand new systems in the future. Next slide, Dale, please. So these storage arrays, they sit in the data center, but there's a lot of metadata that they produce in general. The metadata includes environmental sensors such as the temperature, vibration, the kind of commands that the customers enter, how much data. These are performance and diagnostics type events. When a piece of hardware fails, if an overtemp is detected, for instance, the fans go high, and they're continuously producing this data. And this is actually sent back to HPE for analysis later. But we also send actual use case information, such as the number of volumes that the systems have created, how often those volumes get deleted, how often those volumes get expanded, and so on. So the use case for us on the back end is to figure out not only how the system gets used for us to devise new systems and new policies and new designs, but also to try and understand if the customer really needs to expand their system, for instance. This is what they call a sales and marketing opportunity. If the system is oversubscribed, if its capacity is completely exhausted, or we can actually even project when the capacity is about to get exhausted. So we can actually have the right person call the right customer at the right time to make sure not only they get their system upgraded, but they don't actually run into issues later. We also use the system's backend to deal proactively with potential issues with the system. So for instance, if you notice a high number of drive failures or overtemp conditions, often we actually recognize that the system is in overtemp condition before the customer realizes their data center has actually gotten hot, right? Because an AC failure takes some time for it to actually start to show itself. But since our systems are able to see the temperature and kick up the fan and call home, we actually often call the customer saying, hey, did you realize your data center is hot? So that's the kind of stuff that we actually use our systems today for. But as you can imagine, as the number of systems have increased, we have a lot of data coming home. And unfortunately, from the get-go, we designed these systems, they produce lots of text files, right? So the condition of the system is one text file. The number of volumes that the system has is one text file. What commands have been entered is a text file. And these come in on a regular basis from these tens of thousands of systems back into the headquarters, right? And we really needed to do some sort of real-time versus historical analysis and trends on these things, and they're very difficult to do with text files. When we had a few thousand systems, it wasn't so bad, but once we get into nearly 100,000 systems, it essentially becomes an impossible task. It takes days to run those commands if you just run it over the text files. Next, please. So we talked about the scale. The scale was essentially tens of thousands of arrays, approaching 100,000, and each one of those arrays individually produces, hundreds of files a day, right? And as you can imagine, the number of data entry points that actually come back to headquarters now transits to millions per day. And the volume data keeps growing for a couple of reasons. Number one, we obviously are deploying more and more arrays in the field, but also over time, as we upgrade the software, we realize that we actually need additional telemetry information to be able to give a better, customer experience to our customers, right? So a combination of, software upgrades that, demands more information to be analyzed back home, and also the large volume of the systems out there essentially means the scale keeps growing. And these text files obviously need to be analyzed on a continuous basis, but they really need to be converted to some sort of analyzable format, right? Always looking for individual information inside the text files is not particularly efficient if you have millions of them distributed over a whole bunch of different servers. So we took an initial stab at this by having a process by which these individual files information were getting grabbed out of the text files and inserted into a database. In some cases, the actual text files themselves, if they were small, were getting inserted into a database as a blob, right? And this quickly became overwhelming to the database. In fact, we bought one of the most expensive servers that we could from HP, and it had a terabyte of RAM and the largest database instance that we could actually configure. But over time, within 6 months, it was essentially not really operating at the level we wanted to, and the queries were taking a long time, and any sort of hiccup with the database was essentially preventing us from being able to analyze their data, and in some cases to actually do a timely reaction to an event into the customer environment. Next, please. So what we had to step back and say, okay, so this mechanism using, either directly looking at text files, using, various homegrown scripts was not going to scale. Inserting all that data into the database wasn't really working for us. And we started looking at, so what are the possible opportunities for us, and what can we do here, right? And the obvious answer was Apache Hadoop. We are not exactly kind of big data experts here, and we had day jobs, but we really had gotten to a place where we had no choice but to look at another platform. And we did some experiments on Hadoop, and it looked like it could handle the job. So that's what we actually ended up deploying, right? And that became kind of our plan of record in terms of inserting all that data. It fit the model of having millions of text files on that platform and being able to consume thousands of text files per hour, seems something that can actually be done on that platform. But obviously, the next piece is that how do you actually analyze this data when it's landed on Hadoop? And we actually looked at a bunch of technologies, and the one that seemed to fit our needs best was Arcadia. It really was architected for the big data, and it really kind of directly ran on the Hadoop cluster, so it didn't really require us to go and reinvent the wheel and reinsert our data or do a bunch of data transformation. And as I can imagine now, we have hundreds of terabytes of data, and it really is not that easy to sort of convert it from one format to another format. The other piece that was really nice is we had, from the get-go, several use cases in mind for our data, right? The use cases were either for the engineering to understand how the systems are being used, for the support staff to provide back-end support and quickly analyze, and also for sales and marketing to find additional marketing or sales opportunity, right? So we really wanted a platform that can satisfy the needs of these very distinct groups, and that not only are they distinct in their needs, but they're also very distinct in their ability to deal with the data and the level of competence in terms of the level of the kind of interface they could use, whether it's a direct SQL interface or a GUI interface, and also be able to actually change the models that are presented to them. Next, please. So this actually worked quite well for us. This was something that took some less time than we anticipated, really, because the Arcadia folks were quite helpful in sort of understanding what the use cases are and what the limits of the system are. And after 6 months, we essentially have a system up and running, had the system up and running. And we are loading about 60 gigabyte worth of data per hour. That's the amount of data that's coming in from the field, and we are actually sticking it into the Hadoop with the Arcadia front end. And one of the big issues we wanted to do is to have a series of pre-built reports for marketing and sales folks, right? Things like the utilization trends, failure notifications, failure trends, the various cycles, and so on. And so we kind of had, with the help of Arcadia people, we built that. But the other nice thing is that the data queries that could be modified on the fly to sort of drill down and understand what you're looking. So these are not static. And our previous model, where we were kind of running these reports overnight, and the next morning you had these reports, but you had what you had. You really couldn't change the reports and drill down and say, well, I'm going to look at the details of this particular system or the details of this subclass of systems, right? With the Arcadia, it's quite easy to go and actually say, well, this is a report that talks about the entire field, but I'm interested in this subclass of systems because they just were released and we want to know what the experience is in the field, right? The other piece is that we talked about the fact that we have multiple users of the system, right? And we really didn't want to mix up different users having access to different parts of the system. So for instance, we're sensitive about our customer names, obviously, and we really don't want necessarily to have everybody access to the system. So while you may need access to the failure analysis data, you may not need access to whose system you're analyzing the data failure analysis against, right? So this kind of limited access and this authorized users model that Arcadia provides helped solve that particular problem for us as well, because that's something that we initially knew we had to handle, but the only way we handled it was to literally just limit who could access the data, which made life difficult. But in this model, you just let them access it, but you set up the access privileges ahead of time. The other pieces that was difficult for us to do, our model was always, we were looking at the last snapshot of the data from the data that ran last night, right? Which really didn't help with the historical data analysis. We did some historical data analysis, but a typical historical data analysis will take a few days to run because we have to grovel through lots of data. Now, once the data is actually inserted into Hadoop, and then you have a SQL interface in front of it, the historical data analysis actually becomes possible. This is the kind of thing that really helps us understand if there's a trend. For instance, if a particular feature of the system is no longer in use, or a particular feature of the system is picking up use, that's the kind of thing that matters to us, because it essentially heads off our ability to figure out what sort of features of the system we need to focus in terms of development, right? And this was really, for the first time, we were able to do unstructured data analysis using kind of a well-understood interface, as opposed to always inventing a new mechanism on the fly, because each file was a little different and each need was a little different, which was a very ad hoc model. While it worked initially, over time, it essentially became very burdensome for us. Next, please. So, we talked about the various use cases, but one of the use cases we were looking for was to help the sales folks, right? And it turns out the sales folks actually had developed their own database, but it turned out each region and each salesperson kind of managed their own arrays or their own set of customers, and they have all sorts of different ways to handle figuring out what the needs were. But by having kind of a consolidated system and a set of interfaces, we are able to sort of provide the sales folks the ability to sort of project what their customers, when their customers are going to run out of either physical space or performance on a particular array. So we can head off and say, hey, Mr. Customer, you really need to add storage, or this storage array is running out of performance. You really think about either migrating some of the loads, and we could actually even tell them what set of arrays in their data centers are underutilized, so they could actually rebalance the load among their arrays. And if they are just truly out of performance or capacity, because all their arrays are fully utilized, then there's an opportunity for them to add another array into the environment. And this is kind of interesting. Customers really like it when you head off disaster. They don't really mind spending money if it heads off a disaster, an embarrassment for them, in the production side. And the other piece that really helped us was, being able to systematically look at our component reliability. We buy a lot of components from different vendors, right? And not all of them have the exact same kind of reliability factor, right? And in the past, it was quite difficult to figure out if a particular vendor's drives are more reliable than another vendor, right? Or within a vendor, if a particular set of drives have particularly low reliability. And it turns out that we actually noticed a trend in one of our vendors in terms of reliability, because we could do the historical analysis, and it became quickly very obvious that the drives were not having the typical early life failure, but they were having, a failure that was occurring 3 months into it. And this was kind of very unusual, and they had missed it, and we had missed it, because we could just swapping the drives. But after a while doing the historical analysis, it became obvious that there's a specific thing that's happening a few months into the life of the drive that is causing a very high failure rate. And that helped us, go back to the vendor and work with the vendor and figure out what's going on. And in this case, luckily, there was a firmware fix that we could apply very quickly to our customer to prevent, additional failures, right? And of course, the last piece I talked about a lot, kind of from an engineer that designs the system. I very much like to understand whether a particular feature we added to the system is used or not, right? Because often we invent things and the customers may or may not use it. And the fact that if they use it, we know that's where we need to focus to sort of for additional enhancements. And if a particular feature isn't really being used, do we deprecate that and sort of save resources on the engineering side to focus on what actually matters to the customer, right? And then, I talked about the processing times always being kind of overnight in the past, but now it's done in minutes. And often this really leads to us being able to ask questions that we couldn't ask, because every time you run a query, you look at something, additional questions comes up, and an additional drill down possibility comes up. And these kind of complicated queries that we could run in seconds really has helped us. For instance, I talked about a particular drive family having issues, within 3 months. That's the kind of thing that would have taken a dedicated person spending weeks on it, versus this stuff just popping up on a graph within a few minutes of choosing that particular drive type and a particular lifespan. And this is something that came from support folks saying, can you sort of do an analysis on this? And we looked at it, and it really popped out and was quite obvious. Next, Dale. So here are some of the examples of graphs that we use. The graphs include things like the number of drive types deployed in the field, the state of those drives. So very quickly we can get a sense of what the deployment model is, but beyond it we can actually figure out over time what the mix is. And the mix is interesting because we look at not only just the drive counts, but we also look at drive capacity. And that's the kind of thing that gets lost sometimes in the shuffle, because you could say you have 800 of something, but 800 of this type of drive and 900 of the other type of drive, but that's just the count. But in terms of capacity, the 800 may over dwarf the 900 because they're just larger capacity drives, right? And that tells us the kind of optimizations that we actually need to do. And the other piece is that each one of these drive types, they tend to have different performance profile. So the actual performance available to a particular system is a function of the type of drives that are deployed in that system. So just looking at the drive count by itself is not as illuminating as looking at the drive count and the drive type. And that gives you a much better picture of what the available capacity in terms of performance on that system really is. Next, please. So this is another one. This is where the support folks care a lot about whether the field is updating to the latest software revision, which tends to have a lot of fixes. And this actually helps us. This kind of very colorful graph gives you a sense of the trends in the software install base. So for instance, if you look at the middle one with the red, you can see an increase and then a decrease. And then the pink is taking over and the brown is taking over. So that's when a software release is actually introduced in the field. And as you can see, as a new software release is introduced, it starts to take up more and more, and the older software releases get upgraded to the new software release. That's the kind of graph that helps us understand which set of releases can be deprecated and patches don't have to be introduced. And beyond it, what sort of, if you find a particular release of the software that is particularly vulnerable, this gives us a picture as how quickly we can actually go and deliver patches to those customers to put the system in a much healthier state. And the one on the right shows actually the sub revisions, not just the main release, but the various patch updates that go into the customer environment. And often we can sort of very quickly tell if the environment, if the pool of the systems are in a healthier state, because we do know which of the revisions of the software are the most reliable. So that's part of it. And then the other piece is we can also look at the actual license uptake, right? And the trend that license uptake uses, so we can actually figure out which set of licenses are being used and not being used, and whether and why they're not being used. That's when we go back and figure out with marketing and product management, why is it that a particular software license is no longer being acquired, is a change in technology, is a change in the marketplace, and whether we need to do something in terms of marketing to actually get that particular license, more of those software licenses sold, right? And in fact, it's not depicted here. One of the big changes that we did, we were changing our licensing model, from the model where each license was being sold at a piecemeal versus a model where the licenses came pre-built, and we wanted to have 2 or 3 simple license models. And we use this data to figure out whether it will have a significant material impact on us if we change our licensing model. Next, please. So this is the other piece we talked about. The failure analysis is a big part of a storage array that doesn't work is not it does not make for a happy customer. So over the years we've done a lot of detailed analysis of our drive failures, and drive failures, it turns out they're just not mechanical. Sometimes there is correlation between a particular drive and the firmware that is on it, right? And that's the lower right-hand picture, right? So we are actually able to control for the quality of the firmware on those drives, because what we notice sometimes is a physical drive fails, but not because mechanically it failed, but because there's issues with the firmware that drive. And so we're actually able to look at a particular drive family and look at a particular firmware for a particular drive family to see if they have a higher or lower, failure rate compared to their brethren. And we could actually even do that over the performance, because we could actually look at the service time from the drive based on the firmware, because sometimes a particular firmware and a particular drive actually causes performance issues, and that's something that actually needs to be looked at carefully to keep the system healthy over time. Next, please. So this is, we talked about, sales opportunity based on, both the capacity and performance, right? And this is the kind of thing that we actually used, and we can actually go back to the customer saying, look, this system is about to run out of space. You really need to think about updating. And this is a graphical depiction of that conversation, where we are able to actually look at, not just the customer, we could actually look at it, by customer type, by system type, by region, and that helps, a particular consumer of this data to only see the data that matters to them, as opposed to, the data across the entire install base that may not be as useful to a particular person, or for, somebody that cares for the entire system, for the entire install base as a whole, right? Next, please. All right, so the other pieces, we talked about all these events that are coming back. Well, it turns out that what we've noticed is sometimes the systems emit a particular event right before a failure, and there are predictors of failure to occur sometime later. And this is a particularly powerful tool for us, right? So for instance, you can imagine a system failing in 2 days if a particular event is emitted 2 days earlier. So if we could sort of make those correlations, that means that, we have 2 days to react if a particular event is emitted, for us to go do something about that system before the failure occurring, right? So, we are able to actually do some analysis on failure and then go back and look at the actual events that have been coming back before the failure and try and find these telltale signatures and discover systems that are vulnerable to the failure, right? And this is an example of, the queries that we could do. So for instance, we can look at a particular event getting emitted across 31 billion events that come in a week, and in 8 minutes figure out those events that are concerned to us. If you just want to find a sample of those events to see if they're actually even getting generated, it takes only a minute or so to run it. But this is the kind of thing that essentially means that we could take quality to the next level, and we could actually have, different versions of this report pre-built. So if somebody's concerned about software, because there are different people concerned with software or hardware or different portions of the hardware, they can really only focus on the type of event that they're concerned with. Is it being drive? Is it being power supply? Is being the software itself emitting some sort of fault? Some sort of event that is an indicator of a fault for us, right? And this has helped enormously in sort of, figuring out the behavior of the system, and sometimes, misbehavior as it may be. Next. So that's where the other piece becomes interesting, is that we can actually combine looking at structured data and unstructured data in a sense, right? We could look at the trends and figure out if a particular system, for instance, is having issues, or a particular set of systems are having issues, and we can drill down and look at the actual raw event log. So a moment ago, I talked about the fact that we could actually look at, a trend of systems of drive failures, but we also want to look for these telltale signs that may be going off, and those telltale signs are often hidden in the raw event files. And this is where we are able to actually look at a particular event, a particular trend, and then look at the actual ensuing events on that particular system to say, so these are probably contributing factors, and then we can actually, use that information from the raw event file and go back and now create a query based on that particular event and try and capture it on a real-time basis, on a continuous basis, to head off potential issues. So, in the previous slide, I talked about the fact that we can sort of look for these signature events, but the question is, how do you find the signature events? Well, this is how you find the signature events. You look at a set of trends that are happening, They look at the raw event file via this screen. And then once you find the raw event, then you're able to actually do this backward analysis. Next, please. So if you really have lots of devices like us that produce a lot of data, you really need to think about a big data platform in your production environment. And you really should think about this scale ahead of time. And that's a mistake we made. We sort of had a few thousand devices and we could do it in an ad hoc way. But over time, you really need to build something that can accommodate a lot more than that. And you know, you may be able to do things with the standard platforms, but you will spend a lot of time trying to fix it over time if you don't think about it ahead of time carefully, right? And the other piece is you should think about not only the data that's coming in, but the consumers that are going to use that data, right? That's the other piece that matters, that you need to architect your system ahead of time to think about the security aspects of it. Who are the actual users that are planning to use this, be it customer support, being marketing, being sales, being engineering, and just architect it from the get-go to handle those various use cases. Thank you.
Great, thanks so much, Siamak. Great presentation. And one thing that I really appreciated is your comment about customers really liking, the ability to avoid disasters. And I think that definitely validates a lot of what I'm hearing around this notion of predictive maintenance. So rather than, scheduling maintenance or reacting to some problem, being able to detect and be, much more efficient, much more smarter about maintenance to avoid some of these disasters. Putting some of the effort up front to put a plan in place to be able to do the predictive maintenance versus, using the more reactive model, I think is very important, particularly when it comes to collection and analysis of IoT data. So thanks again, Siamak. That was great. And to all our reviewers, hope you gained some great insights on what you should be considering when deploying your IoT, analytics, and big data environment. Now, if you'll indulge me, I'd like to ask you to spend just a few seconds responding to a quick poll. So I'd just like to know and share with the rest of the audience, where are you with your big data or data lake deployment? So are you still in the gathering knowledge stage? Are you working on the strategy? Are you actually piloting or maybe even deployed? Or would you say you've got a very, very well-oiled system that's fully operational? So I'll give you a few seconds to respond. Okay, so let's take a look at the results. And, interesting that no one's in the piloting phase, but it is a bit what I expected in terms of the early stages of gathering knowledge and developing strategy. It's fascinating that many of you have already deployed some use cases and are probably getting some value. So hopefully this webinar was good in terms of giving you some additional ideas. Maybe you're expanding out from a traditional data lake to incorporate more real-time data feeds or even IoT analytics. So looks very interesting. And of course, some of you are fully operational, so good for you. And hope you continue expanding out your deployments and try to get more value from that. All right, so now let's continue with the webinar where I'll talk a bit about the higher level concepts around big data and how it relates to IoT analytics. I also want to talk a little bit about how Arcadia Data addresses some of the requirements that you might have in your analytics environment and really think about when I talk about some of the features and how we address some of the requirements, think about how you're addressing some of those requirements, how it might be the same or different from what Arcadia Data has to offer, and then also think about some of the other requirements that you might want to address. So one thing I like talking about is the phenomenon that we're seeing out in the market today where enterprises are seeking two separate BI standards. And what that means is that they typically have a traditional BI platform from one of the big popular BI technologies, and they use that for the data warehouse. And it works pretty well. And for all of their requirements, all of their use cases, they're pretty set there. But they also have a complementary analytics platform, which is their data lake. And they're also realizing that they need a separate BI platform for that data lake. Now, the reason why you have, to go back on the platform level, the reason why you have a separate data warehouse and data lake, you probably are very familiar with. Just to quickly review, some of the things I hear about include, the flexibility for handling more types of data and, more sources from both within your organization as well as from external third-party sources. And then with that additional data, you can do a lot of data correlation and enrichment, so you get a lot more value from your data. And of course, as you're bringing in more data sets from both internally and externally, you will face a scale challenge. So how do you address scalability in a very economical and cost-effective way versus using the traditional route of simply upgrading your servers? And of course, some of the advantages of the data lake that people talk about include things like self-service and data agility. And those terms basically mean, how do you try to minimize the overhead of IT as much as possible? I mean, certainly not eliminate it completely, because there are some tasks that are IT required. But if you hand off an analytics platform to a non-technical business analyst and business users, how do you make sure that they can get the most out of the platform without having to constantly go back to the IT team? So let me talk a little bit about how data and platforms have changed along the way, and I won't go into too much detail because I think most of you get this. I mean, data, when it started getting really popular with the relational databases many years ago, you remember that it was all about data from people who typed it in, and so definitely it was very constrained. It didn't grow very fast. You didn't have a lot of the challenges that you face today. But now that you have real-time data sources, sources being created by systems, the volume is much more significant. And then the platforms evolved along the way. And so as some of these newer data sources look to be very interesting, the platforms grew along with them. Now, certainly some of the traditional platforms have evolved a bit. So you might see relational databases incorporating data types like JSON and handling other various complex types, but only to a certain level. And so some of these other modern data platforms like NoSQL and Apache Hadoop and Apache Kafka are intended to be able to handle some of these bigger challenges around data that you might have within your environment. And interestingly, not only are platforms responding to the changes in data, but I think that the platforms, as they evolve, encourage more types of data so that you can have them both growing and evolving over time so that you're trying to do new creative things within your organization. And that brings us to the BI tools. If you think about what has progressed in the BI tools over the years, they largely still have the same model of the rigid schema upfront lifecycle that you find in relational databases and data warehouses. And if you're looking at some of the advantages that you want to get from your data lake, then naturally it would seem like you would need an upgrade to BI tools to handle the data lake environment. So if you talk about, excuse me, if I talk about some of the advantage or some of the challenges that we're seeing within the industry, when you're trying to use a traditional BI tool that was built for data warehouses in a data lake environment, one of the things that you'll face is inefficient scale. And that kind of makes sense if you think about the model around traditional BI tools, which in many cases, when people try to deploy them on data lakes, they're treating the data lake simply as another repository. Not a unique repository, not a progressive repository, but something just like the data warehouse. And that means that you're going to move some of your data from that data lake to a dedicated BI server. And when you do that, you have a compromise. You have to compromise on scale. So you can have a lot of data volume, but only a few users, so not a lot of concurrency, or you can have a lot of users on just a subset of your data. So again, you're not getting the full value of all the data that you have put into your data lake. And there's a notion about not really being efficient at handling data variety. So with all the different data types that are coming in, particularly the newer complex and nested types that we're getting in IoT environments, you really can't take advantage of it, because while a lot of these BI tools nominally say that they can handle newer data types, what's really happening is that the IT team is involved and does a lot of transformations, performs a lot of transformations in the background to be able to put it into a format that these traditional BI tools can handle. So a lot of work to be done whenever a new data source comes in, whenever the data source changes a little bit. So that inhibits some of the self-service ability that you want your business users to have. And then finally, that's related to that previous comment about a variety of data types is related to this notion of agility and lack thereof. So if you think about the model that you get from a lot of these traditional BI tools within a data lake environment, a lot of times what you're really doing is having the IT team do a lot of work in preparing the data, and a lot of times that's unavoidable. So you go through that, but then you want to hand it off to your non-technical folks and let them explore the data, go through discovery, build dashboards, and so on, and then deploy a production application. But if there are any changes that are required in the underlying tables and the underlying data, then they have to go back to IT. So essentially, business analysts only get a very narrow window in terms of what they can do in a self-service manner. And if you think about it, if you think about any self-service application you've seen on the web, you might be able to do a bunch of things by yourself, but up to a certain limit. And then when you're trying to ask questions or do anything that wasn't baked into the application at the very beginning, then you just go back to the IT team. So what we're trying to say here is that for an analytics environment, especially when you're trying to promote self-service, try to give as much of the capability to the non-technical folks so that they can run the whole life cycle by building the dashboards and deploying to production so the business users get access to the data as quickly as possible. And if I talk from an architectural standpoint to compare some of the architectures that are available out there, the first was what I referred to earlier around the BI server, the dedicated BI server within a big data analytics environment. So you have your BI front end and then a BI server where you move your data. And it's that BI server that typically is the bottleneck for a lot of the things that you want to do with big data. So it can't scale out. It wasn't designed for that. So it's typically not a cluster, but rather just a single server that does the analytics. You have to move data into it. And then you have to do a lot of the activities like the transformations and securing the data within the BI server as well. So not an ideal configuration for when you have a data lake and you're looking for some of these new advances that, and the new flexibility that you can get versus a traditional data warehouse environment. And the next architecture that I'm referring to here as the big data BI architecture largely has to do with middleware. So if you think about it, middleware is often about connecting two disparate pieces together that otherwise would be very clunky in talking together directly. So you have the BI tools on one hand, and then you have the data repository on the other hand, or the query engine, and then your middleware plugs in and oftentimes handles things like query acceleration, so that when you're running repeated queries in the context of a dashboard or an application, you get fast responsiveness. And again, because these two tools, the traditional BI tools and the query engines designed for big data, typically don't talk to each other that well. And there's some limitations there. This middleware is trying to resolve that communication, but oftentimes there's a translation at the lowest common denominator level, and so you lose a little bit of the granularity and fidelity of the information that's being passed back and forth. So you don't get the types of optimizations that you could if you had a native connection. Which brings me to the third architecture, this notion of a native BI architecture. And that essentially means that you have an end-to-end platform that includes information from the dashboard as part of the processing so that you can be more intelligent about what optimizations to create. And not only that, you can create some seamlessness around the whole analytical lifecycle so that business analysts could, for example, build a semantic layer and then build visualizations based on that, share the semantic layer, share the visualizations, share the dashboards, and ultimately push to production with a minimal involvement of IT. And that's what we like to call not only native BI, but this notion of lossless. And so if you have as part of your platform, the dashboards tightly integrated with a back-end query acceleration engine, then you have a lot of information to use for some of these optimizations that you need in a big data environment. So let's take a look at it a different way. So if you have your data warehouse, this notion of running something on your data warehouse is simply not possible. And the reason why I bring that up is this whole ecosystem around Hadoop was all about being able to run services or applications on the same nodes as the Hadoop cluster. And so you get a lot of advantages around data locality, meaning that your processing is pushed close to the data, so you're not reading over the network. You also get some advantages around parallelism and certainly scale. But this model is not supported within a data warehouse, which is okay. So we just say that we move the BI server to a separate cluster. Now here's where the problems arise. So as part of the analytical process, you probably want to optimize at a physical level. So that simply means building a schema that's designed for the use cases that your end users need in an optimal way so that they get the fastest responses possible. There's also the semantic layer that, typically your IT team will put together. And that simply is about developing the business meaning on top of the underlying tables. So that would include giving a more human readable name to some of the columns. So if you had something like FL_date, an IT person might know that that actually stands for flight date and might spell it out as part of the semantic layer. So again, just some metadata that helps define, what the meaning is behind the underlying tables. Then you have to secure the data, of course. In any environment, I would highly recommend that security is baked in as part of that initial step. So it's not about worrying about security later. It's always about thinking about security from the start. And then loading the data, of course, is going to be an important step. Oftentimes a very IT heavy task because some of these traditional technologies require building that schema up front. So you're doing a lot of the schema building before you can actually load and get started. And what this means is that you're doing the analytic process on both the data warehouse and the BI server. So you're duplicating a lot of effort. And so the redundancy adds a lot of time. And now think about some of their big data requirements when it comes to things like having that native connection. And I talked about how having that tight integration allows you to share more information from the front end to the back end, and thus leading to some greater gains around efficiency and optimization. Semi-structured and multi-structured data is going to be important. The parallelism and real time. And so you only get them to a certain extent in the best cases, but oftentimes you really don't get these big data requirements addressed. And that's where a native environment makes a lot of sense, especially when you're deploying a data lake. And so if the analytics are being run on the same nodes where the data resides, you get a lot of these efficiencies. And that means that you're not running this analytic process on two separate environments. You're just running it on your data lake, and you address a lot of these big data requirements. So one thing I want to talk about specifically with regard to Arcadia Enterprise, our flagship product, but you should also think about in how are you going to address it in your data lake environment, is accelerating your queries. And so if you look in the bottom left of this diagram, there's some set of your workload that are going to be ad hoc queries, meaning that nobody else has run that query before and possibly no one else will run it again. So, when you're doing the data discovery, you'll run a bunch of queries, maybe even type them in. And because the system knows nothing about these queries, oftentimes you have this expectation that it's going to be a little bit slower. But what about queries that are going to be run across many different users? You want that to be fast, and that's where Arcadia Enterprise can help with the notion of analytical views, which are simply data constructs that are stored within your big data cluster, and that helps to accelerate a lot of these queries that generally have a lot of commonality across the board. So even if you have many dashboards, a lot of these queries have some similarity that can be addressed by analytical views that help return the queries in a very quick way. So that's one aspect. And so you've probably heard a lot of other technologies out there that are able to help with speeding up queries. But what is the process involved in creating those optimizations? And oftentimes that is a really time-consuming process and definitely requires a lot of IT help. What if the system can watch queries for you and be able to determine what are the right data structures to build to help boost the performance? And that's what smart acceleration is all about in Arcadia Enterprise. So you have a recommendation engine, watches the queries, understands what are the relationships between queries and dashboards, maybe even, and also even understands some of the characteristics of the dashboards, like filters and filtering options. And so understanding that can help to build optimizations for queries that are important that may not have been run often, but nevertheless are recognized to be important because they are in the dashboards. So gathering a lot of that information in that native environment helps to build the most optimal analytical views to boost your environment. And to give an example of what it means to boost a query in terms of performance, in this chart, I just gave it, we recently ran a benchmark that included a bunch of queries, about 38 of them, and this is a report that we'll be publishing soon, but here's just a sampling of the queries and their response time. If you look in the lower left, you'll see that the label says accelerated next to unaccelerated. And what that's saying is that if you look very carefully, there's a bar that's very thin, just a sliver compared to the brown bar. And so the thin sliver of a bar represents the response time for an accelerated query, and the brown bar is the same exact query run on a SQL on Hadoop engine that was not accelerated. So you'll see that there's a stark difference when you do leverage the query acceleration in Arcadia Enterprise. And you'll see that stark difference across the board, across these different queries. And along the bottom, from a bigger picture standpoint with regard to concurrency, you'll see the numbers 5, 10, 25, and 95. That represents the benchmark that we run in terms of concurrent clients to give you a sense of how these things perform when there are many users together. And you'll see that for 25 and 95, we don't have corresponding numbers for the unaccelerated queries because they took so long to respond, but at least I wanted to show you how the accelerated queries compared to some of the smaller concurrencies. And it still looks pretty good. So you get a lot of concurrency despite having complex queries. And this does not even include the caching capabilities within Arcadia Enterprises. So you can get a further boost from in-memory caching that's being done on top of the data structure-based acceleration. And let me go through this really quickly, but what I'm trying to outline here is just the long process it takes if you treat your data warehouse, if you treat your data lake as if it were a data warehouse using traditional BI tools. So you have a number of steps, like you land and secure, you're doing some transformations. You necessarily have two separate environments. Again, the traditional BI server alongside your data lake. And so when you go through these first three steps, you're really limiting your time to access your data. So a number of steps along the way, you're going to move some data, and then you finally get to the analytics discovery phase where your business users and business analysts will be able to explore the data and then define the use cases. And so you've lost a lot of time along the way before you can even start the performance modeling. So contrast that to a native environment where you do the landing and secure as well, you build a semantic layer and do the analytical discovery. And what's interesting here is that steps 2 and 3 are next to each other and often done by the same team, the business analyst. So there's a very quick feedback loop between adjusting the semantic layer and the analytic discovery. So that greatly reduces the time to insight. So now we're talking about days versus weeks or months. And then as I talked about the smart acceleration, if you can push this out to some of your users and have them go through the dashboards and be able to get a sense of, have the system learn from those queries and optimize, you're again removing a lot of the overhead from the IT team and freeing them up for some of the other tasks that are responsible and not have to worry so much about performance because the system will take care of it for you. Okay. Just quick summary there. And just summary, scale without compromise, enabling real-time analytics, unlocking complex data, acting directly on your data for data discovery, and a very easy optimization and productization step. And so just quickly overview of Arcadia data. I think we're running out of time, but I just want to talk about this notion of data blending. So not only do you have access to your data lake, but you can incorporate other sources like Apache Kafka and other data sources so that you can get that full view of data, including sources that are traditionally relational, but you can include as part of your dashboard. And to wrap up my portion, there's a lot of information that you can read. Check out our resources area in arcadiadata.com, and feel free to download Arcadia Instant as well and check it out. So thanks for listening. Let me check out some of the questions that have come through. So I think we have time for a few questions here. And if we don't get to your question, we can follow up afterwards. Let me ask this. CMOC, let me ask you this question. So one question came in is, did you get any pushback along the way? If so, who are the detractors?
Well, the biggest pushback really came from folks that had been initially comfortable with using the RDBMS, the old traditional database, because they were really comfortable with that model, and then they just were listening to the fact that the performance wasn't going to scale, and at some point in time we just had to sort of let it be until the system just couldn't scale anymore, and then they came around. So that was our biggest sort of issue. Sort of people who had built the model and they felt comfortable with it until it was obvious that it wasn't going to scale anymore.
Okay, great. And here's another question. I think it's related, and I think maybe this is directed for your opinion. At what point did you believe that Hadoop was the right direction?
I think I talked about using a DBMS. It turns out that we actually used a number of different type of databases, right? Some of them that are supposed to scale better than others, right? And it was really after the third try that we decided that we really just needed to rethink it. And at that point in time, when we sort of did a quick POC of seeing how quickly we can load the data into the Hadoop, and it became pretty obvious that Hadoop could do the job where the others just simply couldn't do it.
Okay, great. And which of your users / departments would you say are the most innovative?
I think, initially I would have said engineering just because I have my engineering hat on, but over time I've realized that there is a lot that goes on in the product management team in trying to understand how the system is utilized, how to sort of deliver, the best mix of features and function. And ours is a complex product, lots of software and lots of hardware. And for us to devise, and we have several lines of businesses, several lines of products, right? And to figure out exactly, what lines of products and with how much memory and capacity and what sort of physical config, there was a lot that they had to sort of think through. And, they came back with some really good ideas in terms of how do we actually kind of build systems that are much more useful to the customers, right? Even around licensing, for instance, they sort of eased up the licensing when they looked at the actual trends in the data center and how people were using the system. So, innovation is a funny word sometimes, because if you just make if customers' life easy by just changing the selling motion or changing some feature on the box, that's also the innovation in the sense that it helps the customer deal with the overall infrastructure in a much more seamless way.
Okay, great. And let me ask you one last question. How much of a factor was speed of your incoming data?
It became a huge factor over time. We had gotten to the point where we couldn't process data for 24 hours. So the data had come in, and we weren't even able to actually process data, and that time lag was just growing, right? And at some point in time, it became obvious that we needed to get something that goes much faster. And we can never go real time, but now we are within a few minutes of the data that had arrived, processed, inserted into the system and ready to go, right?
Awesome, great. So I think we're at the top of the hour. So thanks again, CMOC. Really enjoyed having you on this webinar, and thanks for everyone for joining us today. If we didn't get your questions, we'll follow up with you. And again, we will send out the recording to this webinar in a few days, so you can have that to watch again at your leisure or share with your colleagues. So thanks again, and see you next time.
Thanks.